Today we're going to apply the things that we learned yesterday about all the different kinds of angles and how they're related when the lines are parallel. The key is this: for every problem, the very first thing you have to do is make sure that you've got two parallel lines and you're going across them on a transversal. So for example, when I'm looking for x, I don't want to go from side to side. I don't want to go along this line that's parallel to this line. I want to go across those. So you always want to be crossing parallel lines to have any kind of relationship at all. Angle x has no relationship at all with this angle that's 73, at least in terms of its size. Okay, so if we're going this way, what kind of angles are the x and the 102? We'll take a volunteer. Same side interior, exactly right. Now, does someone else remember what's true about same side interior? And I'll give you the hint. It starts with S. Yes. They're supplementary, exactly. So I just take 180 minus 102. That gives me that x is 78. Then when I want to find angle y, again, I don't want to go left and right because then I'm going with the parallel line. I want to cross the parallel line. So I want to be going this way, cross the parallel lines. Again, I'll take a volunteer. Tell me what kind of angles are the y and the 73? And you got to know these names. Yes, Stetson. Okay. Yes. Yeah, they're alternate interior angles. The same side interior angles are supplementary. All the other ones with names are congruent. So this is 73. So all you got to do is make sure you're going the right direction. Same is true on number 2. If you're trying to find x, do I want to go up and down or do I want to go left and right?
Up and down.
Why?
Because there's like the arrows and that means that they're the same.
But that's not what I want to do. I want to go across the parallel lines, not with the parallel lines. So if I go this way, there's no relationship between the x and the 74 because this line doesn't cross two parallel lines. What I want to do instead is I want to go this way. So I'm going across the parallel lines. Now, x and 81 aren't any kind of angle that has a name. And so sometimes people go, well, what am I supposed to do then? Well, I would either use vertical angles, and I usually use those if I can, or linear pairs. 81 and this angle are vertical angles, so this is 81, no matter what. Even if the lines aren't parallel, that's true. And then the x and the 81, what type of angles are those? Same side interior, so they are supplementary. So I take 180 minus 81, and that's 99. Then for the y, do I want to go side to side or up and down? I want to go side to side because I want to go across the parallel lines. What kind of angles are the 74 and the y? Same side interior. So they are supplementary. 180 minus 74 is 106. If on these, by the way, some students have told me that they like to, when they're doing these problems, if the line just suddenly stops, they just go ahead and make it longer. So that it looks more like this one. If that's helpful to you, that's a great idea. Doesn't take any time to speak of. And if it helps, good. All right. Now let's look at this next one. This one sometimes bothers students because of the way that it's drawn. In this case, both the top and the bottom and the left and the right are parallel. So we've got lots of choices. But if we're looking at x, we don't want to go with the parallel line. We want to go across it. So we want to go this way. Let me change colors so you can see it. We want to go this way when we're trying to find x. We're going across this line and this line. So, because I'm getting the same volunteers all the time, I'll start calling on people. Isaac, what kind of angles are the 47 and the x? Very good. They're alternate interior. And then, Chris, tell me what's true about the alternate interior when I've got parallel lines? They're congruent. Exactly right. So x is 47. Let's do different color. Let's do that. All right, for y, I don't want to go with this parallel line. I want to go across it. Well, it's the same transversal that we used on the last one. What kind of angles are the y and the 35? Yes, ma'am. Alternate interior, exactly right. Can you also tell me what's true about them when the lines are parallel? They're congruent. Very good. So this is 35. Now, with z, you're like, oh, wait a minute, I don't want to go along the parallel line. Well, you're going to have to go along one of them. It really doesn't matter which one, though. Let me switch colors again. Let's do that. All right. So let's say I go this way. Here's angle Z. I'm going up here. Here's the other line that's parallel to this line. This whole angle is 82. If I add the 47 and the 35 together, I get 82. And if I just look at the 82 and the Z, I think this one's a little harder to see because of this line in the middle. If that makes it hard for you to see, well, get rid of it. What kind of angles are those two angles? Same side interior, exactly right. So how are they related? They're supplementary. Again, the one with the S's is the one that's supplementary. So I'll do 180 minus 82. And that's 98 for Z. Questions about that so far? All right, so now we're going to get to some where we're going to have to write equations for some of them. Let's look at number 4. Again, both pair of lines are parallel, so I can go any direction I want. However, if I'm trying to find x, if I go this direction, the only thing down here is an algebraic expression. There's no number. So that's not going to be helpful. But if I go this way, across the parallel lines, what kind of angles are the x and the 80? Anyone? Corresponding. What's true about corresponding angles when the lines are parallel? They're always congruent. So this is 80. Then when I'm trying to find y, that's actually pretty helpful because now I can go this way. And what kind of angles are the y plus 12 and the 80? Yeah, those are corresponding also. So what's true about those? I'm sorry, I just didn't hear it. They're congruent, yeah. So that angle is 80, but that's not the value of y, is it? No. Y plus 12 is going to be equal to 80. Subtract 12 from both sides. We've got y is 68. And now for the z. The z is going to require a little bit more work. Because either way I go, if I go up and down, the 80 and the z plus 15 aren't any kind of angles. And if I go this way, they aren't any kind of angles either. I could try doing vertical angles. If this is 80, then this is 80. But that's not any kind of angles. And if this is 80, this is 80. Those aren't any kind of angles. So I'm going to have to use linear pairs. This angle is going to be 100. The angles in a linear pair always add up to 180. So what kind of angles are the z plus 15 and this 100? What kind of angles are they? Congruence, how they're related. Pardon? Corresponding, yeah. And so they are congruent. So z plus 15 is 100. Subtract the 15. We get that z is 85. Just real quickly, by the way, on a problem like that one, if you don't want to spend as much time thinking about it as we just did, if both pair of lines are parallel, here's what you can do. If this is 80, this is 80. Pick that same relationship up, and it goes in every single one of these corners in exactly the same places. All those are going to be 80 then. Subtract that from 180, and all the rest of the angles are going to be 100. That doesn't take very much time at all. And now you have what x is, and you can write an equation for y, and you can write an equation for z. All right, for number 5. If I'm looking for x, do I want to go left and right or up and down? Which way do I want to go? I want to go left and right because? Well, we don't want to go with the parallel line. We do want to cross the parallel lines though. So we want to go this way. What kind of angles are the x and the 112? Same side interior, so they are supplementary. So I'll just take 180 minus 112 is 68. Then when I'm finding angle y, do I want to go left and right or up and down? Left and right. I still want to cross the parallel lines. I want to go this way. What kind of angles are the y and the 58? Alternate exterior. And if they're not same side interior, all the other ones that we've named are congruent. So this is 58. Excuse me a moment. I'm sorry?
When's our next test or quiz?
We have a quiz this Friday, and then the test is next. It's across 2 days because all the days are short next week because of homecoming. The test will be part on Wednesday, part on Thursday.
Days are short because of homecoming?
Pardon?
Days are short.
There's all kinds of stuff going on. We'll talk about it later. So, shh, Peter. So then y and z, what kind of angles are y and z? Everybody needs to know this one. They're a linear pair. So if you take 180 minus 58, that's going to be 122. Notice, unlike the other one, you can't say all of these acute angles are going to be 58 because we don't know that both pair of lines are parallel. That only works if both pair of lines are parallel. All right, let's take a look at this one, and then we're going to go on to a completely different kind of problem. For number 6, if we're looking for x, which is down here, do we want to go side to side or do we want to go up and down? We're going up and down because we're crossing the parallel lines. Now let's see, the parallel lines are here and here. What kind of angles are the 2x plus 3 and the 46? They're corresponding. So they are congruent. This is 46. So 2x plus 3 is equal to 46. Subtract 3 and we get 2x is 43. So x is what? 21 and a half. We switch colors. For the y, again, we want to be going up and down. And here are the two parallel lines. What kind of angles are the 63 and the 3y? So they are supplementary. You're all over this. Very nice. So 3y plus 63 is equal to 180. Subtract the 63 from both sides. And we get 3y is equal to 117. So we get y is 39. And then we stuck z in here. Notice z is not made by any lines that we know are parallel. So this has nothing to do with what we just learned. But what do we know about these three angles together? Since this is a line, what do they have to add up to? 180. So 46 plus 63 plus z has to be 180. Let's see, that's 109 plus z is 180. Subtracting, we get that z is 71. All right, questions about any of those? All right.
Wait, I got a quick question.
Yes, sir.
I just kind of look at it for a second.
Yeah.
Wouldn't you do since we got 71 for z, and then wouldn't it be to find the x? Since these go the same way, couldn't you do since z is 71, 63 plus 71 equals 2x plus 3? To find
You can do 63 plus 71 plus 2x plus 3 is 180.
Oh yeah, that's what I meant, sorry.
Yeah, you can do that.
Cool, thanks.
Yeah. Frequently, there's more than one right way to do this. I try to do it the easiest way with everybody in class, but there's more than one right way sometimes. Very nice. Okay, so we're going to learn today about a new kind of problem that you haven't done before called a proof. This is where you're given some information and a diagram, and you're asked, prove that this is true. When you do this, you make, and there's more than one right way to do this, but we'll typically do what's called a two-column proof. Sort of like a T-chart like you did in algebra. The first column is labeled the statements. And the second column is called the reasons. A statement is something that you're asserting to be true. I know this is true. I know this is true. The reason is, how do you know that it's true? The reasons are going to be definitions or theorems or postulates that we already have. So, for example, on this one, my first statement, I've got to have a reason that goes with it. I always just write down the given to start with. Your book sometimes writes part of the given, and then later on in the proof, they write a different part of the given. I think I'm just too lazy to do that. So far we know that angle 1 is congruent to angle 2. I always mark the diagram. Why? Because sometimes these get complicated with stuff all over the place. I also know that R is parallel to S. So I'll mark that R is parallel to S. If I know that R and S are parallel, if I go this way with angle 1, there's no other angle up here for me to compare it to. But if I go this way across the parallel lines with angle 2, I have angle 3. And what type of angles are angles 2 and 3? No? Corresponding. They're in the same location. So when lines are parallel, what do we know about corresponding angles? They're congruent. So I'm going to say, okay, if I know these lines are parallel and this transversal crosses them, I know those angles are congruent. So I'm going to say that angle 2 is congruent to angle 3. Now, I used to make people write out what the theorem said. You can just write the title. You don't have to write the whole thing. The title of that is the corresponding angles postulate. And you can abbreviate corresponding and postulate and angles, which says when lines are parallel, the corresponding angles are going to be congruent. This is the only one that's a postulate in what we're doing currently. The rest of them are theorems. Well, now look, if angle 1 is the same size as angle 2, and 2 is the same size as angle 3, what should be true about 1 and 3? They've got to be congruent. If 1 and 2 are congruent to each other, and 2 and 3 are congruent to each other, well, then 1 and 3 have got to be congruent to each other. This is angle 1 is congruent to angle 3. This is called substitution. And it's a property and it's almost always going to be something like that. 1 is congruent to 2, 2 is congruent to 3, so you stick the ends together. 1's congruent to 3 then. and that's approved. They're usually not this short. They will get longer. We're not going to get crazy with them. In my honors class, we get some that are 10 and 12 steps long. You're not going to do any that are that horrible, especially not on this first unit. All right, let's look on the next page for the next one. So again, I'm going to start by drawing my two columns and labeling them. Yes, I do expect you to label your columns. The first column are the statements, and the second column is the reasons. My first statement is just to restate what was in the given. What is it that we know at this point? The reason I know that it's true is because it was given to me as true. I'm going to mark the diagram before I go on to the next step. T and D are parallel, and angle 3 is congruent to angle 2. For this one, there's actually two different places that you could start. Because I want to be going across the parallel lines, I could use either line R or line S as my transversal. It doesn't matter which one we do first. Let's say that we do this one. So we're going across the parallel lines. What kind of angles are 1 and 3? They're corresponding. And when the lines are parallel, corresponding angles have to be congruent. So I'll go, okay, that means that angle 1 is congruent to angle 3. How do I know that that's true? That's the corresponding angles postulate. Again, this is the only one that's a postulate. Any of the other ones are theorems. Well, let's see what I can do with what I know. If I know angle 1 is congruent to angle 3, and angle 3 is congruent to angle 2, what can I say then? Yeah, I can say that angle 1 is congruent to angle 2. Perfect. All right, if 1's congruent to 3 and 3's congruent to 2, I can just substitute and say 1's congruent to 2. That's the substitution property. Unfortunately, is that where I wanted to end up? No. So I'm like, okay, let's go back to the diagram, see what else I can add to this. I haven't talked about angle 4 at all. Well, if I go along the transversal S, I'm crossing two parallel lines. What kind of angles are 2 and 4? Alternate interior angles. And when lines are parallel, alternate interior angles have to be congruent. So angle 2 is congruent to angle 4. What tells me that is the alternate interior angles theorem. And again, you're welcome to abbreviate all of that. So I've got 2 is congruent to 4. Well, now look what I have. 1 is congruent to angle 2. Angle 2 is congruent to angle 4. So if angle 1 is congruent to 2 and 2 is congruent to 4, then I can say that angle 1 is congruent to angle 4, again by substitution. Okay, any questions about that?
How do we know when to stop? Like trying to give statements and reasons.
You stop when you get to the prove statement.
Oh, okay.
Yeah, that's sort of like your goal.